So today we're going to continue with systems of equations. But this time we're going to solve systems using the addition method. So sometimes elimination is called the addition method. Okay, so we're going to get a few steps for doing this one. Okay, so your first step, you're going to rewrite each of your equations in standard form. And that just means bringing all of your variables to one side. And that's only if it's necessary. And that's ax plus by equals c, where a, b, and c are just numbers. Okay. So this step, sometimes it's necessary, sometimes it's not. But if necessary, multiply one or both of your equations by a non-zero number. Okay. And you want to do that because once you add them together, you want either your x or your y to have the same number but different signs. The coefficient of a chosen variable are opposites. Okay. So if you have 3x in one, you want to have negative 3x in the other. If you have negative 12x in one equation, you want to have positive 12x in the other. So you want to make sure they're opposites. Okay. And then once you do that, you add your equations. And solve for the variable. That did not eliminate. Or that you did not eliminate. Okay. So if you eliminated your x, that means you would have solved for y. So now you get that one and you plug it in. Okay. Plug your answer from step 3 into either one of your original equations.
Thank you.
And you can check it if you want to. It's not mandatory. Check, and that's completely optional. All right, so let's say, for example, so you want to solve the system by elimination. Okay, so if you have x plus y equals 7 and x minus y equals 5. Okay. So step 1 would be to make it to where it's in standard form. All your variables on one side, which you have. You have your x and y are both on the left. So your first step, you're already set. Bless you.
Thank you.
It's in standard form. Now for this one, your second step is already set. You don't have to do anything. Because your y, you have a plus y and a minus y. So they're opposites. Okay. So the y terms are already opposites. Okay. So you don't have to do anything for that second step. Yes?
For the second step, though, would you do it for both the x and the y, or just one of them?
Oh, no, you have to multiply it all the way across.
Are you going to show us one where we have to do all the steps?
Oh, yeah, I'll show one for all the steps and some where you can skip some of the steps. So if you run across anything, you would have seen it before. Okay, now for your third step, you just add your equations. Okay, so if you have x plus y equals 7 plus x minus y equals 5. Okay. Now if everything's done right, x plus x is 2x. Then you have positive y and negative y, they cancel out. Then you have 7 plus 5 equals 12. So that gives us 2x equals 12. Divide both sides by 2. You have x equals 6.
How come the y terms cancel out, but the x terms don't?
Oh, because they're opposite signs. So as soon as you add a positive and a negative, it just becomes 0. Which is really the key to this entire process, is making sure at least one of them cancel out. Okay. Now, once you have one of them, you just pick either one of your equations and plug that x into it and solve for y. Plug x equals 6 into either equation. Okay. So if we pick x plus y equals 7. Okay. If we plug in that, bring that up a little bit. That gives us 6 plus y equals 7. Where if we subtract 6 from both sides, we have y equals 1. So your solution, your xy is just 6, 1. Okay. So sometimes you can just go right into adding them together and solve it from there. Yeah, I'll leave that up for a few more seconds. All right, so let's say, for example, what if you want to solve by elimination? Well, if you have negative 2x plus y equals 2, and negative x plus 3y equals negative 4. Now, we could very easily just add 2x to both sides and use substitution, but you have to solve this one by elimination. Excuse me. Okay. Now, first, we have to make sure it's in standard form. All of our variables are on the left, so we're good there. Already in standard form. Okay. Now for this one, the second step is necessary because if we just added them together right now, neither one of those would disappear. We wouldn't get rid of any variables. Okay, so we want to have it to where if we add the x's together, it would disappear, or we add the y's together, it would disappear. So we can multiply every term here by negative 2. Because negative 2 times negative x will give us positive 2x, and we'll add and it'll cancel out. Or we can multiply every term up here by negative 3, because we'll have negative 3y plus 3y, and it'll cancel out. So either one will work. You don't have to pick a specific one. So let's say if we have negative 2x plus y equals 2, and negative x plus 3y equals negative 4, we'll pick the first one and multiply each term by negative 3 to eliminate the y. Okay, so that means if we do that, we have negative 2x times negative 3 plus y times negative 3 equals 2 times negative 3. Now the second equation you're not going to touch. So you still have negative x plus 3y equals negative 4. Okay, so if we go ahead and simplify this one, negative 2 times negative 3 is positive 6, so we have 6x. Y times negative 3 gives us negative 3y. 2 times negative 3 is negative 6. And the second one stays the same. So we have negative x plus 3y equals negative 4. Okay, now once you do that, now you go ahead and add them together, which is our third step. Okay, so if we go ahead and add them together, 6x minus 3y equals negative 6, and negative x plus 3y equals negative 4. Okay, so you have 6x plus negative x, which is just 5x. And if you did it right, one of them should disappear. In this case, it's that. Bless you. So you have negative 3y plus 3y. They cancel each other out and become 0 once you add them together. So negative 6 plus negative 4 is negative 10. Okay, so we end up with 5x equals negative 10, where if we divide both sides by 5, we have x equals negative 2. Now, once we solve for one of our variables, we just plug that into either one of the variables, the equations in the beginning, and solve for the other one. Plug into either equation. Okay, so if we have negative 2x plus y equals 2, I'll plug it into that one. So negative 2x plus y equals 2. That means we have negative 2 times negative 2 plus y equals 2. Bring that up some. Negative 2 times negative 2 is positive 4. So you have 4 plus y equals 2. We subtract 4 from both sides. We have y equals negative 2. That means your solution is negative 2, negative 2. And you can just check it by plugging it into both of them. All right, so any questions on this one? All right. I'll leave that up for a few more seconds.
If you would have used the other equation,
Mhm.
negative x plus 3y, when you bring the other negative 2 in, for because that's what x equals, it'd be negative negative x, or would you then fix that?
For,
Or is it,
you mean if we use,
because you said you could use either
This one?
equation, yeah.
Mhm.
Since it's already in negative 2,
Yep.
would that become positive then?
Yep, so if you use this one, if you multiplied each term by negative 2, you'd get positive 2x.
Okay.
Yep. So then that x would disappear instead.
Gotcha.
All right, so let's say we want to solve by elimination. We have negative 2x plus 5y equals negative 11. And if we have 4x minus 3y equals 15. Excuse me. Okay. Now for this one, it's already in standard form. All the variables are already on the left. Okay. So that step you're good at. Now if you look at it, if you added it together, you wouldn't eliminate any of your variables. So you know you're going to have to multiply something by something. Okay. So really here, you can multiply this whole equation by 5 and this whole equation by 3, and you'll get 15 and negative 15, but that's more work than you have to do. But if you multiply just this first one every term by 2, then the x's would disappear. So you have negative 2x plus 5y equals negative 11, and 4x minus 3y equals 15. So for this one, we're going to multiply each term by 2 to eliminate the x's. Okay, so that means we will end up with 2 times negative 2x plus 2 times 5y equals 2 times negative 11. And the second one just stays the same. So you have 4x minus 3y equals 15. Okay, so if we simplified the first one, 2 times negative 2x is negative 4x. 2 times 5y is 10y. Equals 2 times negative 11 is negative 22. And we still have 4x minus 3y equals 15. And if you wanted to, you could just add it right from that step. Okay, so if we went ahead and added them both together, you have negative 4x and positive 4x, which if you add them together is just 0. So that worked out just the way we planned it. You have 10y minus 3y, 7y, equals negative 22 plus 15 is negative 7. So you have 7y equals negative 7. Divide both sides by 7. You have y equals negative 1. Okay. Now whatever answer you get, you plug that into either equation. So plug into either equation to solve for x. Okay. So it doesn't really matter which one we plug it into. We'll get the same answer either way. So plug it into negative 2x plus 5y equals negative 11. So negative 2x plus 5y equals negative 11. We know that y is equal to negative 1, so that's negative 2x plus 5 times negative 1 equals negative 11. Okay, so that gives us negative 2x minus 5 equals negative 11. So if we add 5 to both sides, bring that up a little, that's negative 2x equals negative 11 plus 5, which is negative 6. Divide both sides by negative 2. Means that x is equal to 3. So that means our solution is 3, negative 1. Bring this up a little bit. There we go. Okay, so any questions on that one? All right. Okay, looks like everyone's done writing. Okay, so solve by elimination. say negative 3x equals y minus 12, and negative 4x plus 3y equals 10. So your first step is always to make sure it's in standard form. Okay. So that means that negative 3x equals y minus 12, and negative 4x plus 3y equals 10. You're going to subtract y from both sides. That means you have negative 3x minus y equals negative 12, and negative 4x plus 3y equals 10. Okay, so this is the one you're going to use. Okay, so now for our second step, we know that if we added it together right now, nothing would disappear. Okay. So really, if we got this first one and multiplied it by 3, our y's would disappear, because we'd have negative 3y and positive 3y. So that means negative 3x minus y equals negative 12, and negative 4x plus 3y equals 10. At first equation, we're going to multiply each term by 3 to eliminate the y. Okay, so that means for our first equation, we're going to have 3 times negative 3x minus 3 times y equals 3 times negative 12. Okay. You want to make sure you do each term. A lot of times you'll multiply, I'll see people multiply just one of the terms and then it throws everything off. You want to make sure you do each of the terms. So negative 4x plus 3y equals 10. The second one just stays the same. Okay, so if we go ahead and simplify those terms, 3 times negative 3 is negative 9. So we have negative 9x minus 3 times y, so that's minus 3y, equals 3 times negative 12 is negative 36, and the second one just stays the same. Okay. So now if you want, you can go ahead and just add it from right there. Okay. So you have negative 9x minus 4x, which is negative 13x. And then minus 3y and plus 3y, they're opposites, so when you add them together, they disappear. You have negative 36 plus 10, which is negative 26. So that means we end up with negative 13x equals negative 26. Divide both sides by negative 13. We have x equals 2. Okay, now this x equals 2, plug into either equation to solve for y.